Hey there Tuggers! Long time no see. But don't worry, I haven't been slacking off. I've cooked up a fantastic and brand new Udemy course just for you. Blender Dive into the 3D World. This course is perfect for anyone brand new to Blender and 3D modeling. Hobbyists, people dreaming of a new career, or even pros who just want to brush up on their skills. And to kick things off, I'm saying hello with a massive discount, up to 95% off for the first month only. You can grab the discounted course using the link in the video description, or you can just type in the code you see right now. In this video, I'm going to share one of my favorite lessons from the course, Normals. For more free lessons, have a peek at the other previews available on the course page. Alright, I won't keep you waiting any longer. If you want me to keep making videos like this, just hit the like button or drop a comment below to let me know. Let's jump into the lesson. The orientation of surfaces in Blender, Normals. Hello and welcome back. In this lesson, we are going to cover one of the most fundamental yet most confusing topics in 3D modeling, Normals. Once we understand Normals, we'll learn what other commands and modifiers use them, and our control over our model's shading and appearance will increase tremendously. So, what exactly are normals? In the simplest terms, a normal is a vector perpendicular to a face or vertex that represents the direction the face or vertex is pointing. Every surface has a front and a back. Normals determine this direction and control how objects interact with light and how they appear in Blender. A face normal pointing in the wrong direction can cause faulty shading in your render or cause modifiers to work incorrectly. A 3D model is defined by two main elements. The first is its geometry, the concrete shape created by the combination of vertices, edges, and faces. The second is its shading, how the model interacts with light and how its surface appears. There is an invisible yet vitally important force that brings these two worlds together, normals. Normals are the most critical connection between a model's geometry and its final visual presentation. Without them, even the most complex and detailed model remains a mainlinks pile of shapes. Let's use an analogy to better understand this concept. Imagine a 3D model as a complex sculpture made of countless small mirrors. The model's geometry determines the position and arrangement of these mirrors in space. However, the normal of each mirror defines the exact direction that mirror is facing. If you want to know how the sculpture will look when you shine a light on it, you need to know where each mirror is aimed. Is each surface a flat mirror placed separately, or is it a curved mirror that bends and influences its neighbors? Normals are the surface's aiming direction. Now, let's learn how to weave and correct normals. Weaving normals. To weave normals, let's select an object and switch to Edit mode. Mesh Edit Mode Overlays menu. Let's click on the Mesh Edit Mode Overlays menu, which has an icon that looks like a selected single vertex on a face, in the top right corner of the interface. Normal Weaving. In this menu, we'll see three different options under the normal heading. When you activate these options, you'll see small lines emerging from your surfaces or vertices. These are the normal vectors. Turquoise vectors symbolize face normals, blue vectors symbolize vertex normals, and pink vectors symbolize split normals. Display face normals. Shows the normal of each face. It's a vector that emerges perpendicular from the center of a face. It determines which way the mesh is facing. For example, a reverse face is invisible when Backface Culling is enabled. There is a single normal for each face. Display vertex normals. Shows the normal of each vertex. It's produced by averaging the normals of the faces that share the same corner. Modeling tools, for example, commands that move vertices like shrink fatten with Alt-S, the inflate brush in sculpting, and displace modifiers. Generally use the vertex normal or the vertex-based normal direction. Or, as we learned earlier, when we change the transform orientation to normal in vertex mode and use the GZ command, the selected vertex will move on its own normal, or directly on the normal vector. Display split normals shows the normals that appear on the vertices. These are normals that are specially generated by Blender for shading. When a ray of light comes from a source and reflects off the object, it breaks according to these split normals, and Blender generates the image based on that. To reinforce the explanation, we can view this on an interactive web application which I will publish on my website that is currently under construction. If you see the link in the lessons resource, you can click on it. If we right-click in object mode and select Shade Flat, we are essentially transferring the face normals to the vertices in parallel. This causes the light rays that hit here to break according to these normals, and see it as sharp edges. If we select Shade Smooth, all the object split normals will merge at their average point, and they won't break the light rays individually, which gives us an illusion of a smooth surface or one that is made of a very high polygon count. Auto Smooth, on the other hand, will apply a modifier called Smooth by Angle to our object, and all the edges that are below a certain angle we set here will be smoothed. And the others will be marked as sharp. You'll see this difference especially if you apply the modifier and go into it. So, what was mark sharp again? In previous lessons, we saw that we can mark selected edge as sharp in edge mode. This command is exactly what splits its selected edge vertices, which gives us a sharp appearance, as you might recall from our interactive application. For example, we can also apply the Shade Smooth or Shade Flat command in face mode. If Mark Sharp is selected, even if we apply Shade Smooth in face mode, the normals of these parts will remain split, meaning they will continue to draw perpendicular angles relative to their own faces. Correcting normals. We can use a few different methods to correct normals. First, I want to talk about a viewing command that we use to see the faces with inverted face normals, which in turn causes all normals to be inverted. The command is called face orientation, and we can access it from the viewport overlays menu in the top right. In fact, this is a command that I use so frequently that I almost never remove it from my quick favorites menu. If you want to change the red one, you can press F4, go to Preferences, and from the Themes tab, go to the 3D viewport menu, where you'll see the face orientation back color. You can change the color to whatever you want from here. There is another method to view inverted normals besides face orientation, which is called Backface Culling. To activate this feature, all we have to do is check the Backface Culling checkbox in the viewport shading menu. When we do this, the normals that are not facing us are not rendered at all, and thus we cannot see them. We can't even select them by dragging our mouse. Game engines like Unreal Engine or Unity show inverted normals in exactly this way. If you have an object with inverted faces, you must correct it before exporting. We'll definitely cover this in the export lesson. Recalculate normals. Shift N. This is the most frequently used command for correcting face normals, and its shortcut is Shift N. If there are paths in your mesh with incorrect face normals, you can select all of them in edit mode and press Shift N. Blender will automatically recalculate normals and try to flip them all outwards. This command will solve your problem in most cases. Flip normals. Alt N. If Shift N doesn't work, or if you want to invert normals of specific faces, you can use the normals flip command from the mesh menu. This reverses the normal direction of the selected faces. To access this command more easily, you can use the Alt N shortcut, which will give you access to all normal related commands. The Backface Culling we talked about earlier is not just a rendering option. We also use this intentionally in some 3D model types, like speech bubbles. If we create a sphere, flip the normals with the flip command and place something inside it, we will see the inner surfaces of the sphere no matter where we look from. This is very useful in workflows like creating speech bubbles or outlines for 3D models. So, we might want to intentionally flip some faces sometimes. Merge by distance. Remember that overlapping or extra vertices can also cause normal problems. In such cases, using the merge by distance command with the M shortcut can be an effective way to fix normals. Just like with the extrude and bevel commands, we should never forget to keep the merge by distance command close by. In our previous lesson, we learned to use shade smooth, shade flat, or auto smooth by clicking on our objects. Now, we can understand what they do much better by adding our knowledge of normals. When we use shade flat on an object, you'll see that the split normals have the same number as the surrounding faces and are parallel to normals of the faces they are touching. Which creates sharp edge light refractions. When we use shade smooth, all the object split normals will merge and will extend at the average of normals of the surrounding faces. This prevents the harsh refraction of light between surfaces, which gives the impression that the object is smooth or made of a very high polygon count. Let's go back to the Alt M menu and continue to examine the other commands. Set from faces. You can think of this command as a local auto smooth. It performs a local calculation between the selected faces and merges and averages the split normals accordingly. For example, let's select two horizontal face loops on a UV sphere and examine the difference. When we add shade smooth to this selection, you'll see that it only softens the edges that are inside. But set from faces gives an exponential smooth effect that fades away outwards. Rotate. When we click on the command, you'll notice that as I move the mouse, I rotate each vector. This allows me to have full control over the normals of some models. It can be a very useful command, especially for stylized models. Point to target. The name of the command is already explanatory enough. It makes all selected normals point to a single target. The shortcut for this is Alt-L. You can see all the extra shortcuts you can apply from the key combinations at the bottom when you start applying the command. For example, commands like use pivot with L, use mouse with M, or set and use 3D cursor with Ctrl left mouse button. It is especially useful for creating things like leaves, grass, or specific special effects. split, merge. When we apply the merge command, all split normals will be merged, and thus, a smooth surface appearance will be created. In the split command, the opposite happens. They will be split again, and sharp-edged appearances will be created. This command will even automatically assign mark sharp to the edge in between. Average menu. In the average menu, we will encounter three different options. First, I want to state that all average commands merge the split normals and take the average of the normals. So, why does it offer three different options? Custom normal. If we select custom normal when calculating the average, it will also take the custom normals we've set before into account and try to apply a soft transition based on that. Face area. If we select the face area option, it will calculate an average based on the size of the surface areas. The surface area that is larger will be more dominant and pull the normal vectors toward itself more. Corner angle. This will apply a smoothing operation based on the angle of the ends. The average menu offers us a great deal of control when adjusting our normals with these three options, and I highly recommend you use it frequently throughout your 3D modeling journey. Copy-paste vectors. You can copy the vector of a face you select with copy vector and pass it to all other surfaces with paste vector. It is even possible to copy a vector from one object, paste it to another. This method is perfect for models like grass blades, where the vectors need to be facing in a single direction. Reset vectors. This returns to vectors whose direction has been changed to their default position. Set face strength. Set face strength in Blender is a setting that doesn't directly affect shading, but is used with weighted normal modifier. What does it do? It allows you to set the strength of a face as weak, medium, or strong. These values determine which faces pull the vertex normal directions more when the weighted normal modifier is running. Example use case. Let's say you have a blocky model. When you apply the weighted normal model, it recalculates the vertex normals based on the face strength values. If you set a face to strong, that face normals direction influences the vertex normals at the corners more. If you set it to weak, that face influences the normals less. This helps you get cleaner shading on edge, especially in hard surface modeling. Select by face strength. This allows you to select faces whose face strength you have adjusted based on the influence value. For instance, you can select only strong faces. Sometimes, it is completely possible for you as a beginner designer to not to be able to fix normals. In such cases, the custom normals you have set from the commands in the normals menu will appear in the custom split normals data section in the mesh data menu in the properties. If your model has visual errors, clicking the clear custom split normals data button will fix the problematic appearance. There are two modifiers related to normals: the weighted normals we talked about earlier and normal edit. What is weighted normals in Blender and what does it do? Blender's weighted normals modifier is a powerful tool used to improve a model's shading. It allows you to achieve a clear separation between smooth and flat surfaces without adding geometry, especially in hard surface and low poly modeling. This makes your model look more realistic and high poly. Weighted normals come into play here. This modifier allows you to manually control how normals are calculated at the corners. Simply put, it makes the normals of large, flat surfaces influence the normals of neighboring small or curved surfaces more. This makes large surfaces look completely flat, while the transition in between remains soft. Advantages of the weighted normals blender. Better shading. It fixes shading errors and distortions, especially after bevel and boolean operations. High quality in low poly models. It allows you to create models that look more detailed and high quality using less geometry, which is crucial for areas where performance is important, like game engines. Control without touching geometry. It improves shading by adjusting only the normals, without changing the model's topology. Important settings. Weighted mode. Determines what the normals are weighted by. Face area. Gives more priority to the normals of larger surfaces. This usually gives us the most desired result. Corner angle. Weights the normals according to the angle created by the surfaces at the corner. Face area and angle. Takes both factors into account. Weight. Adjust how strong the weighting will be. 50% is the default value. As you increase the value, the influence of larger surfaces increase. A more constructing result. Keep sharp. Preserves the sharpness of the edges that are marked as sharp. This is very useful when you want certain edges to always remain sharp. Face influence. As we saw with the set face strength commands, this determines that the normals will be more affected and pulled toward the face based on the strength we set here. If we haven't set an adjustment with the weak, medium or strong options from the set face strength menu, this setting will not make any difference. Vertex group. As you know, this is a section we use to determine where the modifier is applied. In summary, the weighted normals modifier is an essential tool that improves the shading quality of your 3D models, especially hard surface objects, making them look more professional and clean. Since I mostly create low poly objects and game assets, I frequently include this modifier in my workflow and remind my students to use it often. Because applying this often automatically fixes shading and saves us a lot of time compared to manually adjusting the normal settings we saw before. Normal Edit Modifier. The name might sound a bit technical, but don't worry, the logic is very simple. When you add the modifier to your object, a few options will appear. Let's go over them one by one. Mode. This menu asks you to which target you want to orient the normals. Radial. This is one of the most popular and useful modes. It assigns normals to the objects as if they were radiating outwards from its center. You can best understand this as, imagine a sphere. The lines drawn from the sphere center to each surface become the new normal direction for that surface. What does it do? It ensures that objects like tree leaves have consistent and smooth shading, as if they were growing from a single center. It fixes the strange shading on the edge of leaves. Directional. In this mode, you orient all normals towards a specific target. You place another object, usually an empty object in this scene, and all surfaces will be lit as if they are looking at that object. What does it do? It is great for cartoon style or stylized looks. For example, you can make a character's face always look lit from a certain direction, even if the camera angle changes. This ensures that the shadows always remain where you want them. Target object. In both modes, you specify which object the normal should be oriented toward. You usually add an empty to the scene and set it as a target. As you move this empty, you'll see the shading on your object change dynamically, like magic. Mix mode and mix factor. Sometimes you don't want to completely change the normals. Maybe you only want to fix a part of the original shading. This is where mix comes in. You can choose one of the options from copy, add, subtract, and multiply as the mix mode. Copy completely removes the old normal, while the others apply their own mathematical operations. You can determine the strength of the effect from the mix factor. For example, you can set the value to 0.5 to apply the effect halfway. The mix factor value of 0 means the modifier does nothing, and 1 means it works at full power. The values in between, for example 0.5, allow you to transition between the original normals and the new normals created by the modifier. This is very important for getting more precise and soft results. The offset value can only be used in directional mode and when parallel normals is active. We can orient the normals by dragging the slider off the axis we want. Where will we use this modifier? Tree and plant modeling. Think of the leaves of a low poly tree. Each leaf plane faces a different direction, which creates scattered, ugly shadows. If you add the normal edit modifier to all the leaves and set it to radial mode, they will have smooth and homogeneous lighting, as if they were all part of a single sphere. This is the most common use case. Fixing shading errors. Sometimes in a complex model, no matter what you do, strange, dark spots or shading errors appear on some surfaces. The normal edit modifier can help you iron out these errors by realigning the normals of those problematic surfaces relative to neighboring surfaces. Stylized art, NPR, non-photorealistic rendering. When creating anime or cartoon characters, you want the light to always behave according to a certain aesthetic rule. By using the directional mode and an empty target, you can ensure that the shadows on the character's face or hair always remain where you want them, even if the camera angle changes. Applications of normals. Let's take a closer look at the applications of normals. In modeling, commands like extrude faces along normals, as the name suggests, work by basing the extrusion on the face's normals. In modifiers, for example, the solidify modifier uses the direction of the normals when adding thickness to an object. If the normals are reversed, the thickness might be added inward instead of outward. In shading, normals determine how surfaces react to light. Incorrect normals cause areas in your renders to look strange, shadowed, or completely black. In game development, game engines only render the front faces of polygons to improve performance. If the normals are reversed, those surfaces become invisible in the game. As you can see, normals are not just small blue lines. They are a vital topic that can come out at every step of the modeling process. You can improve yourself in this area by trying out these commands a lot and observing how the normals look when you open the visual aids. Remember that when we change normals, even though we practically only affect the shading, behind the scenes, they form the working principles of some modifiers like shrink faden, the inflate sculpt brush, and solidify displacement. Remembering this will lead you to make much better decisions about which tool you should continue with. If you've made it this far in this lesson, I sincerely congratulate you. Yes, I know, it was a very long lesson, but normals are a topic that almost every designer I meet neglects. And fully solving this will greatly increase the quality of your models. Remember, a good 3D artist doesn't just make a model, they also control the light and shading. If you're ready, I'll be waiting for you in the next lesson.